looking at the study guide for reflections, I want to draw your attention to two important sentences on that top paragraph. The first one says, if the point does not lie on the point of reflection, then the line of reflection is the perpendicular bisector of some segment that joins the pre-image point and the image point. Okay? So we know that whatever line that we could draw between those 2 points, what we had originally and what we get after the transformation, is going to be 90 degrees to whatever line we're reflecting across. Okay? And the distances on either side are going to be the same. We saw that when we did our perpendicular bisector construction. The other sentence I want to draw your attention to is this one. If the point is on the line of reflection, then the image and pre-image are the same point. They don't move. Okay? We're going to use that to do some of these constructions. Okay? Taking a look at the image, the example here. You can see all those right angles, those perpendiculars. And they're telling me, since this is a bisector, this distance here, whatever it is going to be the same as this distance here. Okay? And you can use your compass to verify. We're just confirming, yup, that distance, I didn't have to move my compass radius. Yup, that distance is the same. These lines are indeed congruent. Let's go ahead and do the construction on number 1. Thank you. Much like the construction you saw in translations, where we had to find perpendicular lines, we're going to do the same thing here. But the line of reflection is our guideline. We don't have to draw one for ourselves. So taking your protractor and again locating your 90-degree perpendicular mark, it's the one that goes through the vertex finder, the opposite direction of your sidelines. We're going to set your protractor up so that that line, I'm going to do it on the other side so I have more line of reflection to work with. And you're going to line up your line of reflection just as neatly as you can on that perpendicular line. Then taking your pencil, preferably with its lead sticking out, put that pencil on the vertex, shift your protractor however you need to, again making sure that it stays perpendicular, and then we're going to draw a line that goes across the line of reflection. I don't know how far, so I'm going to make it way longer than I think I need. Remember, I only really need this distance between the vertex and the line of reflection on the other side of the line. But I went more than I needed. I also added a little arrow to tell myself, hey, I went that away. So when I come back to the next step, I'm not confused. Okay? Let's do it on the other side. Okay, I'm just flipping my protractor around so I have more line of reflection to line up. Okay, so lining up my line of reflection on my perpendicular guide. There it is. And I want to go across the line of reflection, which means I need to go that way. And again, I put my little arrow to tell me, hey, I'm going that way. Do I need to draw one of these lines for K? No, why not?
It's unnecessary.
Why is it unnecessary?
There's already one there.
Because it's already on the line of reflection. And that second sentence that I pointed out to you at the beginning was stating that if it's on the line of reflection, it don't go nowhere. It just sits there. Time for your compass. Using the technique from congruent segment construction, use your compass to find the distance between a vertex and the line of reflection, and make sure that you get that distance along the line that you drew at the beginning, that perpendicular. This is the distance that you will copy on the other side of the line of reflection. So just shift your compass over so that the needle is on the line of reflection. Set your pencil down and draw a little arc to tell yourself that's how far. Repeat for every vertex that you have movement for. I find these constructions really hard because the figures are so small and my compass doesn't like going this tiny. So when I build for you quizzes and tests that are coming up soon in the next, sometime this week, later this week, I will make sure that the figures are a little bigger for you, okay? So you don't have to have your compass so small, because I know that makes it challenging, okay? All right, once you have your marks, it's time for us to label these points. H followed the reflection, it followed this line and ended up right here. That is the image for H, and so it is H prime. J, the pre-image, moved to this location, and so the image for J is J prime. K did not go anywhere, and so its image and pre-image are the same. And so I'm just going to make that point a little stronger and say K prime. Because we want to move the entire figure, time to take out our straight edge again and connect the vertices in the same order that they were connected originally, just like we did in translations. So J and H were connected, so J prime, H prime are connected. HK, so H prime, K prime, and JK, and J prime, K prime. And there's my reflection. I'd like to look at number 2 just briefly, just the setup portion, because we have points on either side of the line of reflection. And I just want to show you real quick how to handle that so that you're not surprised when you have to do it on your own, okay? The process remains the same. I'm going to use my line of reflection to set up a perpendicular. So here you go. You see me setting up my protractor the same way and drawing my line and telling myself which way I'm going. But notice when I get to point P, in order to cross the line of reflection this time, I have to go in the opposite direction. And so I'm going to let myself do that, but that's why I do those arrows, to tell me which way I went at each time. Okay? The process is exactly the same from here on out. Congruent segment construction, use that compass to find distances and mark them off. Label, connect the points, you're done.